Morning students, today we will discuss about the interrupts of 8051 microcontroller. So before going to be detailed in interrupt of 8051 microcontroller, first we will discuss what is the interrupt. So interrupt means an event which is responsible to break the sequence. So in microcontroller, uh, if execution of program is broken due to any reason, then that is known as the interrupt. So here we have written that uh, interrupt is an external or internal event that the microcontroller that the interrupts the microcontroller to inform it that a device needs its service. Generally, input devices interrupts. Input devices are responsible to interrupt the microprocessor for service required. So whenever the input device required the service from the microcontroller, they interrupt the microcontroller. So interrupt means they will break the sequence, the execution of the program which is already executing by the microcontroller. So generally, input devices required service. Microcontroller provide the service to the input devices in two different ways. One is the interrupt and other is the polling. There are two different ways through which the input devices in microcontroller provide the service to the input devices. So in polling, microcontroller continuously monitors the status. Microcontroller continuously monitors the status of the device. Whenever the condition is met, it performs the service. Means microcontroller continuously input device को check करता रहता है कि they are required the service or not. So whenever the condition is met, microcontroller provide the service. After that, it moves to another device. Suppose there are number of input devices connected. So if the first device is provide the services by the microcontroller to the input device in polling, then it moves to another or next device until every device is serviced. तो जब तक कि सारी डिवाइसेस सर्विस नहीं होंगी तब माइक्रोकंट्रोलर पोलिंग के थ्रू उनको चेक करता रहेगा और जब भी वो सर्विस के लिए रेडी होगी माइक्रोप्रोसेसर माइक्रोकंट्रोलर उनको सर्विस प्रोवाइड करेगा. सो इन पोलिंग मेथड status of the several devices and serves each of them certain conditions are met. So the polling method is not efficient since it wastes much of the microcontroller's time by polling devices do not need the service. Polling method में microcontroller को check करता continuously microcontroller check करता रहता है कि they are required the service or not. So in this way a lot of time is wasted of the microcontroller. So hence the efficiency of the microcontroller is also reduced. Whereas in interrupt, whenever any device needs the service, whenever any devices need the service, the device notifies the microcontroller by sending it an interrupt request. जबकि इंटरप्ट में क्या होता है कि माइक्रोकंट्रोलर विल नॉट चेक द स्टेटस ऑफ द इनपुट डिवाइसेस. माइक्रोकंट्रोलर विल डू इट्स ओन वर्क. ठीक है. वेन एवर द इनपुट डिवाइसेस रिक्वायर्ड द सर्विस या नीड द सर्विस, द डिवाइस नोटिफाइज द माइक्रोकंट्रोलर बाय सेंडिंग अ इंटरप्ट सिग्नल. So upon receiving the interrupt signal, microcontroller interrupts whatever it is doing and provide the service to that device who is responsible to interrupt the microcontroller. So program which is associated with the interrupt is called the interrupt service routine program. And after interrupt, microcontroller execute a program, and that program is related to the input devices. So microprocessor executes a program which provides the service to that input devices, and that program is known as the interrupt service routine program. So microcontroller can be interrupted internally or externally, right? So for every interrupt there must be an interrupt service routine program. For every interrupt, microprocessor can many devices can interrupt the microcontroller or microprocessor. ठीक है? So in many ways. So for every interrupt there is a service routine program. ठीक है? And when the interrupt is invoked, when the microcontroller is interrupted, microcontroller runs interrupt service routine program, and that interrupt service routine program is run by the microcontroller to provide the service to the corresponding input output device. So for every interrupt there is a fixed location in memory that hold the address of the ISR. There are a lot of numbers of interrupt service routine program which will be executed by the microcontroller, and those program will already stored in the memory. So microprocessor will require the address of that memory location where the ISR interrupt service routine program is stored. So the group of memory locations that holds the address of ISR is called the interrupt vector table. The interrupt vector table provides the address of the ISR. So in 8051 microcontroller there are 5 interrupts. In 8051 microcontroller there are 5 interrupts. These are the 5 interrupts which are located in 8051 microcontroller. 2 external interrupts होते हैं and there are 3 internal interrupts. Two interrupts, those are known as external interrupts, and these external interrupts are known as INT0 and INT1. They are the 2 external interrupts. ठीक है? Which was means external interrupts means external devices can interrupt the processor through these interrupts. So only two external devices in 8051 microcontroller. 2 external devices can interrupt the microcontroller. So these external devices can interrupt the microcontroller through the port 3 pins, and these port 3 pins are port 3 की second pin और port 3 की third pin. Second pin and third pin of the port 3 will provide the external interrupt. And there are 3 internal interrupts. 3 internal interrupts है, where 2 internal interrupts are the timer 0 and timer 1, 1 for timer 0 and 1 for timer 1. So there are the 2 internal interrupts, and 1 internal interrupts will be required for the serial port or serial communication to transmit the data or to receive the data. So there are the 2 receive interrupt and transmit interrupt. There is the OR means either at a time it will receive interrupt or it will transmit interrupt work. So there are 5 interrupts are available in 8051 microcontroller, 2 external interrupts and 3 internal interrupt. External interrupts are INT0 and INT1, or internal interrupts are timer 0, timer 1 and RI/TI. So 5 आपके इंटरप्ट अवेलेबल होते हैं 8051 माइक्रो कंट्रोलर में. तो इंटरप्ट जब भी माइक्रोप्रोसेसर, हम लोग पढ़ चुके हैं कि जैसे माइक्रो कंट्रोलर को कोई डिवाइस इंटरप्ट करेगा, ठीक है, यदि माइक्रोप्रोसेसर एक्सटर्नल इंटरप्ट होगा या इंटरनल इंटरप्ट होगा, तो माइक्रोप्रोसेसर एक प्रोग्राम एग्जीक्यूट करता है. उस प्रोग्राम को बोलते हैं इंटरप्ट सर्विस रूटीन प्रोग्राम. तो माइक्रोप्रोसेसर को उसको प्रोग्राम को एग्जीक्यूट करना पड़ता है. वो प्रोग्राम मेमोरी में स्टोर होता है. तो माइक्रोप्रोसेसर को इंटरप्ट सर्विस रूटीन प्रोग्राम को एग्जीक्यूट करने के लिए एड्रेस रिक्वायर्ड होता है कि वो प्रोग्राम किस एड्रेस पे स्टोर है. So interrupt vector table provide the address to the corresponding ISR. ठीक है. So here the interrupt vector table is given. int 0 के लिए जो मेमोरी लोकेशन का जो एड्रेस का होगा वो 003H होगा. टाइमर 0 के लिए 00BH, int 1 के लिए 003H, टाइमर 1 के लिए, और CL पोर्ट के लिए ये. तो दिया द एड्रेस which is stored in the address vector table. So at these address the program of the ISR program will be stored, and these are the priority. एड्रेस वेक्टर टेबल में जो सीक्वेंस दिया हुआ है आपको इंटरप्ट का, ये प्रायोरिटी भी डिसाइड करता है कि ये आपका दिस शोज दैट INT 0 एज द हायर प्रायोरिटी एंड CL इंटरप्ट हैज़ द लोएस्ट प्रायोरिटी. तो सबसे ज़्यादा प्रायोरिटी INT 0 की होती है, उसके बाद टाइमर 0 की प्रायोरिटी होती है, उसके बाद INT 1 की प्रायोरिटी होती है, उसके बाद टाइमर 1 की प्रायोरिटी होती है, और सबसे लीस्ट प्रायोरिटी होती है वो CL पोर्ट की. दिस ऑल्सो शोज द प्रायोरिटी ऑफ द इंटरप्ट. बट इन 8051 माइक्रोकंट्रोलर प्रायोरिटी कैन बी इंटरचेंज. जो हमारे 5 इंटरप्ट हैं इनकी प्रायोरिटी को हम इंटरचेंज कर सकते हैं. किसी भी इंटरप्ट की प्रायोरिटी को ज़्यादा कर सकते हैं, किसी भी इंटरप्ट प्रायोरिटी को कम कर सकते हैं. दैट कैन बी डन बाय द इंटरप्ट प्रायोरिटी रजिस्टर, राइट. सो there is a to enable or disable the interrupts, all the interrupts are the maskable interrupts. So to enable or disable them in 8051 microcontroller there is a register, 8-bit register is available to enable the interrupt or disable the interrupts, and that register is known as interrupt enable. That interrupt is known as interrupt enable register. It is a 8-bit register, and this register is used to enable or disable the interrupts available in the 8051 microcontroller. So this the 7th bit, MSB, most significant bit of the IE register, inter enable register, is used to enable all the interrupts. If this bit is 1, if this particular bit is D7 bit of the IE is 1, then all interrupts will be enabled. All 5 interrupts will be enabled. If suppose we want to not, we are not interested to enable all the interrupts, so this bit should be 0, this bit should be 0, and corresponding bits of the IER can be used to set the bit to enable the register. For D01 is reserved to enable the interrupt, external interrupt 0. D1 bits is used, external interrupt 0. D1 bits is used to enable or disable the timer interrupt 0. D2 bits is used to enable or disable the external interrupt 1. This is for the timer 1, and this is for the CL port. तो corresponding interrupt can be enable or disable. Suppose हमें timer 0 interrupt को enable करना है, so this bit should be 1. If this bit should be 1, then the timer 0 will be enabled. If suppose we want to enable the CL port interrupt, then this bit should be 1. ठीक है. So CL port will be interrupt will be enabled. If this bit is 0, then the CL port interrupt will be disabled. So particular interrupt can be enabled or disabled by set or resetting the corresponding bit of the interrupt enable register. Next, interrupt priority register. So as we can say that priority can be changed. ठीक है. हमने प्रायोरिटी का सीक्वेंस पढ़ चुके हैं हम लोग यहाँ पर कि प्रायोरिटी का सीक्वेंस ये होता है. दिस इज द सीक्वेंस ऑफ द प्रायोरिटी. This is the sequence of the priority. External interrupt INT 0 has the highest priority. Timer 0 is the lowest priority than the INT 0. INT 1 has the lowest priority than timer 1. So this is the highest priority and this is the lowest priority. So these priority can be changed by the using the inter-priority register. So it is also 8-bit register. So we can alter the sequence of the interrupt priority by assigning the highest priority to any one of the interrupt by programming a register called the interrupt priority register. So this is the interrupt priority register. This bit is used for the external interrupt to decide the priority of the external interrupt 0, timer 0, external interrupt 1, timer 1, priority of timer 1, or priority of CL port. So we can make any interrupt higher. So by making the corresponding bit of the interrupt register by 1, then that interrupt will have the highest priority. Suppose हमें मालूम है PS CL पोर्ट की प्रायोरिटी सबसे लोएस्ट होती है. यदि हम चाहते हैं इसकी प्रायोरिटी हाईएस्ट हो जाए तो हमें इस बिट को क्या करना पड़ेगा, इंटरप्ट रजिस्टर में इस बिट को हम बंद कर देंगे तो इस बिट की प्रायोरिटी क्या हो जाएगी, हाईएस्ट हो जाएगी. ठीक है, और बाकी की प्रायोरिटी क्या रहेगी, लोएस्ट रहेगी. तो करस्पॉन्डिंग किसी भी की प्रायोरिटी, किसी भी सोर्स की प्रायोरिटी को हम चेंज भी कर सकते हैं. और ये कैसे होगा चेंज, बाय यूजिंग द इंटरप्ट प्रायोरिटी रजिस्टर. ओके, थैंक यू.